Today, we are going to learn QuickSort. Like merge sort, QuickSort is a recursive algorithm. But the only key concept here is that it's all about the pivot, right? You must have heard it a lot, anyways. A pivot is just one of the items in the array, so it's not a very big thing. It is just one value that we are going to take and call it the pivot, and it will also decide a lot of factors, so it is a very special concept here. It has three important roles once the sorting is done. So let me bring pivot here. So you may like have a question, what exactly is pivot in our case. So let's just break down what makes a pivot so special. Firstly, when we have finished sorting, the pivot will be in its correct position in the final array. So what is an array? You know it. We are going to sort elements in an array, and this is uh, an array. That means all the elements on the left. So this is something you need to know. Left, right, and so on all the elements on the left are smaller. So if we take 3 as a pivot, which we are going to take 3 as a pivot for now, all the elements to the left are going to be small, and all the elements to the right are going to be large. So, um, so we have taken 3 as a pivot. So the initial thing that we have to do is that just put it at the end. So I'm just going to change this. Put row at the end. Okay, fine. And no, no, not all this. Not all this. Hmm. Now the first iteration, not the first iteration, but the first step of the recursion. We are going the first phase or pass, whatever you call it. We are just going to find the item from the left. This is the left, larger than the pivot, right? So it here it was. The pivot was here. Now it is here, but before it was here. So this is the element that is larger than the pivot and on the right. So this was larger than the pivot on the left, and we are going to see something like check for something that was smaller than the pivot on the right. So there you go. This was one. So we are going to swap them, right? Swap, whatever. So just let's swap them. So I'm just going to change it so you know that what we did and done. So we have swapped our arrays. We have actually swapped them. No, no. So this was one, this is two, and now we have swapped them. So this is 2186507 3. Now the second phase is that this is the second step. We have done the first thing. Now we have to find the item from the left larger than the pivot. So again, that is 5 again. So we have see, this was when you have put 3 here. This we have done this beforehand. Like consider it when 3 was here. Now consider that 3 is now here. So from here, considering this 5, this is our new, and like I'm just letting you do this. So we have to find the elements larger than the pivot 5, and also the items that are smaller than the pivot, that is 0. So and now we are going to swap them. This is going to be swapped. So now Now we're just going to swap 5 and 0, 5, 0. So this is our third step. Now we have swapped 5 and 0. Now the final swap that we are going to do is that we are going to, as we see, this is a final swap, right? So as we can observe here, that the left pointer has crossed the right pointer, right? So this was the left pointer and this has crossed the right pointer. This has come, the left pointer was first here and now this has come here. The right pointer was here and now this has come here. So you can see the right pointer is now here, the left pointer is now here. So swap the pivot 3 with the left item. So pivot is 3 and the, the left item is 7. This. I think, okay, wait. I forgot to swap these, I think. It's correct. So we are going to swap 3 to this position. We are going to take this 0 here. So let me just do it. Let me draw arrows or 0 will come here and 3 will come here. This. And 8 will go here, obviously. So this is, we just have to bring 3 into its correct sorted position. So let me just do it again. We brought 0 here. Now 8 here. And I remove the 3 from here because it's been swapped. So as you can see that um, it's 210365857. So it is in its correct sorted position with everything to the left smaller and everything to the right larger. So if you see everything to the left is small. 2 is smaller than 3, true. 1 is smaller than 3, true. 0 is obviously smaller. And now 6 is greater than 3, true. This is 8 is 5. All these, as you can see that everything on the left is smaller and everything on the right is larger. Now we just have to, what you have to do is we have to recurse or no, repeat again and again and our sorting algorithm, like not a sorting algorithm but our array will be sorted, and let's just see how we are going to do it in Python code. So let me open my what do you say, Jupyter notebook, and I'm just going to show you there, and I'm also going to provide a screenshot. I don't know if I have something regarding some other languages. I'll just see to on their implementation this in the same way, and I'll give you the implementation for Java and JavaScript as of now, because they are the famous languages that I know about, and that's all. I'm going to code in Python, so let's start. Also, in case I forgot to mention one thing, that find the pivot, actually not find the pivot. See, find the pivot. So we have to choose a good pivot in the first place, right? If we don't have a good pivot, then our sorting won't go this smooth. So uh, and it can also slow down our process. So we want a pivot that roughly divides the array in half. So this there's a very popular method, you can search about it online also. It's called the median of three, and it works that we take the first, middle, and the last elements in our array, sort them, and choose the middle one as our pivot. It's a decent guess that this value is close to the median of the entire array. So consider this as um, three boxes, three, five, two. What we are going to do is that we're just going to do this here. So this is sorted. Consider this one. है ना? So you can say that 2 is the median of the whole array by this method. Um, but it's not always a correct guess. It's a close guess, right? So, but it is a very common method and also easy to use, and it is close to the median of the entire array. So if we take out the median of this whole array, it will be close to 2. But we have taken 3 in for this array because that's what we felt would be correct. Now we are just I'm just going to tell you that QuickSort has a worst case time complexity of 0 of n square. So, not 0, sorry. Why am I so, it's O of n square, okay, not 0, sorry. So, it's O of n square, which can happen if we consistently choose poor pivots. But when pivots are chosen wisely, QuickSort's average is around 0. I'm sorry, again I'm saying 0. Why am I saying 0? O n log n. So it is a logarithmic, you know, it's O n into log of n. If you know about logarithm, if you have studied about in class 8 or 7, it's good. If you have not, then you can just check online. There are many 5-minute tutorials about logarithms, and it is a very efficient algorithm. So let's start making it in Python. So this is the array that we had as our example. So we need to import some. So basically, just going to open it up. Import numpy as usual, and we are going to put this to take. How much time does it take to sort, right? Or maybe this not. Okay, then let's. First, we are going to do the partitioning of the, let's say, array. So we have left partition. We are going to take input as array. We are going to take an numpy and we are going to take a value of low that is going to be integer. We are going to take the value of high that is going to be integer, and it is going to return an array. So now, uh, why is it suggested so much? Anyways, it's correct actually. So basically, the pivot is going to be the uh, array high. Why is it? No, I don't want your suggestions, please. Okay, sorry. Why have I added this decorator ends? So now on left, now we are going to have left. The left wall is not going to be the left side of the array. It's going to be an integer by the way. uh, and it's going to be low. Now we're going to loop for I range low plus 1 and high is going to be high. You are wrong, Copilot. Uh, now check if the array of at on the index is no, less than the pivot, and it's going to do that. If it is, then we are going to implement it's correct now, and we're just going to swap the variables now. So just saying that in other languages, swapping is a bit different. In Python, it's very simple, so please don't feel jealous now. Anyways, so we're going to swap the uh, index of the iteration and the left wall with the left wall. Yes, correct. Please go ahead. And now we just have to swap another variable if uh, whatever I've shown you does not happen, if it is not less than and all that, we are just going to swap them again. It was correct. And now we are just going to return the left one. So it's correct. It's order. Now this is the quick sorting algorithm. Yes. Now we are going to take some inputs. Now array is going to be np.ndir, correct? And why is it in return none? Okay, let's just check if it is actually in return. I will return none. Why is it why has it taken actions? What is going to do pivot? Now the location of the pivot is very important here. Is we are going to partition it. So we are going to use like we are going to decide where our pivot is going to be. We are going to pass the array, the low, and the high. That is very simple. Now we are just going to recursively call our uh, function to the pivot location so that the items on the left are smaller and the items on the right are greater. And then we are just going to QuickSort and pivot. Yes, it was correct. We live life only to know that it was correct. And then uh, we are just going to convert our array into NumPy array or have it. No, we are just going to convert. That's better actually. So our array is going to be np dot array, and we're going to pass. And this also works by the way. I just the first time I learned quicksort was for a school assignment, and I used it to sort names. So if someone, any of you thinks that, how will it sort names? It also sorts names, and I'll show you how. And now just have to um, do quick sort. So our low value will be 0, and the high will be the length of the array, and we are going to pass the array, or that is very obvious. And let's try running this. And it's complete. So I think uh, it took around 1.2 seconds, if you remember. So I think it was quite fast for that. And now just let's check like, how much time it took. So you can also print the array, or you can just do this. will show this is the array 0, 1, 2, 3, 4, 5, 6, 7, 8. It's correct. It is correct and it is going to work every time. And I'm also going to try a very big data set and to see like how with random numbers and like literally random and like I don't know. I'm just going to take a very big number and convert it into a list and I'll show you how much time it takes for that. So we're just going to calculate time as of now, how much time it took. So we can take start time as time dot time and end time as uh, time dot time, which is very obvious. This is a very simple way of calculating time. There are many other ways also. So they are more accurate, by the way. But that this is the only way I've learned, and let's use it everywhere. We are going to use the F string, and we can say that the time taken to sort is correct. And now we can just print the array. So let's run this. Oh wow, it took 0.0 seconds. So let's give it a new. I think we have understood it most. Now let's give it a very very big. I don't know what am I doing. Bruh, this is very big. Basically, I'm just spamming on my numpad. Just spamming on my numpad and hoping to see random numbers. This is the why am I such a bad person? Anyways, now let's run this. Time y. Oh, oh, damn. I did not know this thing, to be really honest. Okay, after some Google searching, I find that I just need to add a string keyword here, and it is fine now. And let's just delete some white spaces. Now let's run this. So you can see this is the sorted. This why is it so big? The time taken was this much seconds. I don't trust this to be really honest because computers are bad at floating math. But then anyways, and you can see that it has sorted. So we can see that there are 0, 0, 0, 0, 1, 1, 1, 1, 1, 2, 2, 2, 2, and so see don't and also for the like words, right? You said for I also said for words. Let's I don't know why I said hard ones. Sorry for that. No, YouTube don't please. I'm a good boy. Anyways, okay. Now let's try with this. And this works, right? So Alexander, Benjamin, Charlotte, David, and all that name I don't know. These are very even hard to pronounce. Anyways, so yeah, it works. It'll work anytime with all kinds of and it how much time it took. It took this much amount of time, so it is really fast. But it all depends on the pivot you take. If you take a bad pivot, it will be very bad. But if you take a good pivot, it will be fantastic. So I think that's all for today. And I'll just add some screenshots for other languages also at that. And yeah, that's I think